Hello viewers, welcome to another episode of Knowledge Sharing. Today we are looking at this question and it says evaluate a to the power of 2 equals to b plus 241 and b to the power of 2 equals to a plus 241. We are going and it says a must not be equal to b. So we are going to evaluate for us to find the value of a and b. From the question we have a to the power of 2 equals to b plus 241. And we also have b to the power of 2 equals to a plus 241. Let's call this equation 1 and let's call this equation 2. So from here we can say we need to subtract equation 2 from equation 1. So from here we can see that when we subtract here from here, it's going to have us this minus here we have a to the power of 2 minus b to the power of 2. We have b minus a will give us equals to b minus a. So we have 241 minus 241 will give us 0. From this situation, this will give us a to the power of 2 minus b to the power of 2. Then transposing this to this other side, we have minus b, then we have plus a equals to 0. So we have this. So in this situation, this is different of 2 squared. What we are going to do, a to the power of 2 minus b to the power of 2 is the same thing as a plus b into a minus b plus a equals to 0. From here, we can see that we have minus b plus a, the same thing as writing a minus b. So we have a minus b here and we have a minus b here. So we can factor it out. So we have a minus b into, when we divide the whole of here by a minus b, we have a plus b. Dividing here by here will give us plus 1, all equals to 0. So in this case, we can see that the first parenthesis is equal to 0 or the second parenthesis is equal to 0. So setting the first one, which is a minus b equals to 0. Therefore, our a will be equals to, when minus b transposed into this other side, it becomes b. But our question says that a must not be equals to b. So this solution is rejected because a must not be equals to b. So from this other side, we have a plus b plus 1 equals to 0. A plus b equals to, when this transposed into this other side, become minus 1. Therefore, we can ask a equals to minus 1 plus b. So this is the value of a that we have from this question. And also, we can write the value of our b, which is equals to a minus 1. But this is, we can ignore this. So this one, we call this equation 3. We have 1, 2, and 3. So here, for the second part, we can say, let's add equation 1 and equation 2. So when we add that, a to the power of 2 plus b to the power of 2 will give us a to the power of 2 plus b to the power of 2. So equals to, we have b plus a, which will give us b plus a. So we have 241 plus 241 will give us plus 482. So here, this is what we have. We can call this equation 4. Okay, this was 3. That is equation 4. So what we are going to do, we recall that equation 3 is a plus b. So we can substitute into this. So we say substitute equation 3 into equation 4. So in this situation, we have a to the power of 2 plus b to the power of 2 equals to, the whole of here is minus 1. So we have minus 1 plus 482. So here will become a to the power of 2 plus b to the power of 2 equals to 481. So we can call this equation 5. So we recall, we say from equation 3, where we have a plus b equals to minus 1. So we can say square equation 3. So this will become a plus b all to the power of 2 equals to minus 1 to the power of 2. So here, a plus b to the power of 2 is the same thing as a to the power of 2 plus b to the power of 2 plus 2ab equals to 1. So this is what we have, because minus 1 to the power of 2 equals to 1. We can call this equation 6. So from here, you see that we have a to the power of 2 and b to the power of 2. And equation 5 says a to the power of 2, b to the power of 2 is 48. So we'll say substitute equation 5 into equation 6. So this will give us the whole of here is 40,481. Then we have plus 2ab equals to 1. So this is same thing as 2ab equals to 1 minus 481. So 2ab equals to minus 480. So this is what we have. But we can find the value of a or b from here. So this will give us ab equals to minus 480 all over 2. So divide there. So our ab will be equals to 2 cancel here and 2 cancel here, 240 minus 240. So this is the value of ab that we have. We can also have b equals to minus 240 all over a. So we can have that. But we need to substitute it for us to have it a. We need to substitute this into our equation 3 for us to have the value of our a. We need to clean this. So we have here from, let's bring down this, a plus b equals to minus 1. This is equation 3. So we need to clean this for us to have space. So we said from here that our b equals to minus 240 all over a. That is the value of b that we have from here. So we need to substitute that into equation 3. In this equation 3, we have a equals to, the whole of here is b, is going to be minus 240 all over a equals to minus 1. So from here, a minus 240 all over a equals to minus 1. So for us to clear this, we need to multiply all through by a. So this will be multiplied by a times a minus 240 times a all over a equals to minus 1 times a. From here, we have a times a is a to the power of 2. A will cancel here. We have minus 240. Then we have here equals to minus a. So we need to move this to this other side. We have a to the power of 2 plus a minus 240 equals to 0. So we have a new solution now, and it's a quadratic equation. What we are going to do is for us to factorize this using factorization method. So we need to multiply 240 by a squared. It's going to give us 240 a squared to the power of 2. So now we need to find two factors that when we add or subtract will give us a. That two factor is 16 and 15. If you multiply 16 and 15, will give you 240. So 16 minus 15 will give you that. So we have a to the power of 2 plus 16a minus 15a minus 240 equals to 0. So here we can put parentheses here. We have a is common here. So a into a plus 16. Then we have here minus 15 is common here. So we have minus 15 into a plus the whole of here, which is 240 divided by 15 will give us 16. So all equals to 0. So we have the two parentheses which are identical. So they are common. We can factor it out. We have a plus 16 all into, when we divide the whole of here by a, it will give us a. So divide the whole of here by this will give us minus 15. Minus 15 all equals to 0. From here, it is either the first parenthesis equals to 0 or the second parenthesis equals to 0. So we said a plus 16 equals to 0. Therefore, a will be equals to minus 16. Then the second one, which is a minus 16. So we have a minus 15 equals to 0. Therefore, our value of a equals to plus 15. So value of a1 is minus 16 and a2 equals to 15. So this is the first and the second value of a that we have. So from here, we are going to use this to find the value of b that we have from this equation. So we need to clean this. So the value of a1 equals to minus 16 and also the value of A2 equals to 15. Then we are going to use this. Here we recall that we have B equals to minus 240 all over A. So for us to find the value of B at when A equals to minus 16. So we are going to have B equals to minus 240 all over minus 16. This one will cancel here. We are going to have 15. Therefore, when we have our A as minus 16, then our B will be equals to 15. So this is what we have. Then the second part, which is A2, this is for B2. Then A2, which we have B2 will be equals to minus 240 all over A at A equals to 15. So this situation, we will have that we have B2 equals to minus 240 all over 15. So 15 will go here and 15 will go here. We will have B equals to minus 16. This is the value of B2 that we have. So here we can further evaluate this as when we have A1 and B1 will be equals to, for A1 we have minus 16, then B1 we have 15. Then A2 and B2 will all have, then A2 which is 15 and also B2 which is minus 16. So these are the value of A1 and B1 that we have, and it satisfies this question that we asked. In this case, our A is not equals to B. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comments, and share our video for more interesting topics. Thank you.